I am not Morgan Freeman, and what you see is not real.
Did you notice this wasn't a real video? It can sometimes be difficult to spot AI-generated videos known as deepfakes, that is, digitally manipulated content where a person's face, expression, or speech is altered by AI.
I think as of today, if it's reasonably good, it's going to be very hard for the average person to detect it by just listening to it or watching it. I see a lot of people ask me, what are the cues I can look at?
Some things that might be helpful now are to look for videos that might have be pixelated in particular areas that are blurry. And sometimes if an image just looks too good to be true, it might actually be fake. When a deepfake is made, it's made on available data, available images. And so the default of an artificially generated image tends to be pretty and pleasing, right? So things that might look abnormal might actually less likely to be deepfaked. But the models are changing. And if somebody realizes that a tip might be a deepfake doesn't blink, then everyone will look around and see that it doesn't blink. And then suddenly we'll have a new method where people are blinking.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time.
If you actually want to have a very good detection system, you have to run a whole series of detection techniques to be able to analyze a particular video or audio.
Deepfake detection tools are technical tools that run kind of the meta-analysis of the video and the audio to see if there's any alterations in between the frames or maybe in the audio. And so they're models that are just looking for the probability that something has been altered. Most deepfake detection tools are...
Well. Am I a deepfake or am I really here? Let's have a look. Can you hear me first of all? I'm just playing around with my mic here, so let's squeeze that in place. I've got a couple of people in chat. Good morning. Well, good evening, everyone. Good evening, AJ. Good evening. We've got Mohammed, of course. David, good to have you back. Esperant, I haven't forgotten. We've got Jake, Mohammed, Norman's iPhone. Prince, good to have you. Solita, good to I'm glad you're here because we're going to talk about your field a lot today. And, of course, a great night time as well. A nice warm welcome to everyone. Hey, it's been a minute, hasn't it? I've completely forgotten myself in the great scheme of things. I was thinking, when was the last time I did one of these things? And it might have been... I think 3 months ago, in fact. So, yeah, no, not much has changed. I'm still in Brazil. I'm perpetually online as it is. Not too bad. Well, okay, so welcome to everyone who doesn't know myself. I'm Marco. I've been with the Academy for the best part of living memory. So with that being said, I have moved over to Brazil in the last year, and it's been pretty well. I'm just in the process of renewing my visa now, which is complicated as things go. They love forms, but they don't like translating them. So that's going well. I'm doing my lessons. I was meant to do them today, but things got in the way. And yeah, not too bad. It's winter time, so we always do we do the switch now. So when it's cold in the UK, it's warm here, and vice versa. So you could theoretically run away from the sun if you really wanted to. But that being said, it's pretty well. What I'm realizing is that they've got a huge tech bubble around here. It's surprising. In fact, they've even got their own Sao Paulo summit. Gosh, coming up in the end of the year. I haven't been to Australia. I wouldn't know about that, but I do know that they're going to do a big show and tell. There was a web summit that my friend was at on last week. I couldn't go to it because it was so expensive, but it was amazing how many people actually turn up for that thing. Web summit is just like it's kind of like Expo, but for everything else, not just AWS included. So a lot of things are happening on the field, and actually. It's a really interesting point about how much AI is taking over our world. I hate to be the one that talks about it, okay, but iPhones are becoming obsolete. Yeah, so the Eric something or other in the last couple of days, I think today he said in the next 10 years or so, we're just not going to have them anymore. And I don't think he's wrong. Eddie Q, who is a top senior exec in the Apple department, Apple have been in a legal bid with, if anyone's following the news, with Apple and the Stripe payment industry. So previously, Apple would be taking a 30% cut on anything related to some purchases in order to just be the only way of buying things. Basically, they took that to court. Epic Games said, you can't do this. The court sided with Epic Games, and now Apple have to allow other vendors to actually use Apple payments too. I think they're kind of moving towards a more tech-based economy and away from hardware. In fact, what I'm seeing here is phones are just becoming slowly a thing of the past. We're sort of following this X-like curve, where one thing goes down, one thing goes up, right? Or like a K, in fact, where I think phones or hardware more generally is just going to be more and more embedded into us, augmented into our fiber, into our skin, and I don't know. Well, who knows what in 10 years will be like from now. Kind of like what happened to the iPod, it just became obsolete. So going down that rabbit hole, it really is just the drive forward that's happening with the world of AI. And it is a love-hate relationship I have with it, because I have to look at it and I have to know about it. But at the same time, it just scares me as much as it entertains me. And what I wanted to do today is actually have a little bit of fun with that. I figured that'd be a good place to start talking. Let's put this on the big screen, shall we? With a good friend, Mr. Pixelated Face. Let me know if you can, in fact, see this. I think I'm showing the right screen. You can see a big blurry face. And if you can't, whose face would that be? If just to be on the right side. I think that's a video that if I click on, there you go. Man. Well, okay. How about this one? Let's put this up on the big screen. So if you don't know who it is, let's call it out.
I'm going to show you some magic. It's the real thing. I mean, it's all the real thing.
Mate, like he looks more like him than he does in real life. You know, when someone
I know.
looks
That's-
more like
that's-
they're
that's normal.
it's not go there. Yeah, it's super creepy. There's a couple of freeze frames here, what I think. No way. But it's getting really good. So this is, of course, a deepfake, a technology by which you can paste someone else's face on another body. So this might not be his, person. There are very, very subtle telltale signs. Yes, this isn't Tom Cruise. If it wasn't obvious, that's because it's so effective nowadays at using the technology, and you can very subtly tell, often with the shapes of the eyebrows, the hairline, sometimes the mouth movements give it away too. This isn't Tom Cruise. It's someone else. It's a completely other person. And so what we wanted to do is just show how we've been using this stuff. How do we arrive at this day today? And using AI, I think more generally within AWS. But also, I want to take a look today at how AI itself works, just to prepare you for the better years ahead with the developing economies and such. And I think amongst our goals today is just to give you a taste of artificial intelligence. I want to give you a sense of how the technology itself works because it's not going, it's not going to go anywhere. Okay, it's only going to become more and more omnipresent, most likely. So hopefully by the end of today's hour, you're going to get here a bit more, at least more of a computer person. But also, the talk of the town has been specifically something called generative AI. Generative AI, like AI, is a field of computer science that has been with us for decades now. But it really is just it's made exponential improvements in the world of in recent months and kind of the last year or so now, should we say. But the focus has been on late, indeed, of Gen AI, and we'll talk a little bit about the talk of town, if I can actually find my login, which I seem to have forgotten. Anyway, we'll get a good look at generative artificial intelligence in order to go ahead and generate some stuff. So I think about this time last year, or if not 2 years ago now, DALL-E 2, which is probably the talk of the town for one thing above all else. If anyone does know or has used this before, this was all the rage when it came to one particular field of technology. If you do know what this might be, Mohammed is interested in AI. Have you heard of this one, DALL-E? This is one that perhaps you're more likely to come across, maybe not by this name. Maybe you have played with this, in fact, whereby you can go ahead and type in some keywords and then boom, you basically end up with a dynamically generated image. So this is what this technology is. It's more for image generation, and there are similar tools as well, just like it. So DALL-E being one of them, Midjourney as well, which gives you likewise some realistic 3D imagery. And so within that world of image generation, there were some nonetheless telltale signs, like an observant viewer could tell that, okay, maybe this was created by AI. I can sort of tell it apart now. Well, I'm so used to it now, I kind of train myself to recognize it. So I want to make this as involved as possible, as we can. So over the last couple of years or so, lots of publications like the New York Times, amongst them, has been testing, like I'm going to do with you, just the ability of people's to discern fact from fishy, okay, reality from AI. So, in fact, this was a few months ago now. So the New York Times, they took a couple of those tools we just looked at, and for instance, here is a sequence of images that, at least at left, it's not that implausible that this might be an actual photograph. It's not out of the ordinary, shall I say, from first glance. But in fact, if you look at them more closely, if you stare at them sort of with a magnascope, you can see all three of them are generated by AI. And so for some time then, the very first earliest drafts of AI were very, they carried a certain tell with them. So like AI, up until really recently, in fact, it just wasn't very good at the finer details. Like, can anyone see what happens to be wrong or is a telltale sign in this case? So looking at the image here, which I'm telling you, is perhaps at first glance not too strange until you realize what? Yeah, the fingers. For some reason, the little hand sausages, yeah, they don't work too well. Sort of the pinky finger's going off this way. It's not quite right in some way. So you could have had that kind of a hint, and this was true for the early versions of Midjourney and the like. But I dare say that nowadays, at least what I've noticed is AI is getting really good at this stuff and better and better and better, such that I think it's getting harder for us to be able to discern those kind of things that previously well-worded signs. So what I'm going to do is I'm going to send over one like this. Oh yeah, I'm talking about the Trump dance. That unfortunately is real. So if you haven't seen it already, he dances the village people an awful lot. Let me go ahead and do this. So what we'll do is send you a link, which, sorry if I'm not entirely sure how this page works. I've just not done it before. Let me just find the link button. Off. Let's put that in the chat. So if you'd like to join in, which I'd like you to do, is just go ahead, and if you haven't done so already, just get your phone out or maybe click on the link I've just sent you in the chat. And if you've got a phone, you can just scan this QR code if you've got one with you. And if you'd like to partake with this, all you need to do is just scan the barcode, which will lead you to a URL, which I've just put into the chat as well too. And on your screen in a moment, you'll have the opportunity to go ahead and buzz in. Before you do anything, before you go ahead on anything on that page, just give a chance for people to join. So it's like a Kahoot, but I just want to ask you a sequence of questions just to see how well you think you are, at least how prepared you are for this coming world of AI, right? So, for instance, once you've got this here code signed, if you don't, that's fine. You can still watch, just, play alongside someone else if you want to, or I'm going to show you. Go ahead. Two images, in fact. I'm going to put them up to screen side by side. And so my question is to you, which of these two images, all right, left or right, would be generated by AI? So you can, rather than putting in the chat, if you want to go ahead and see me how you're performing, where's my pen? There it is. Yeah, so which of these two were performed by AI? So Solita says both.
I think both.
All right, well, some doubters amongst us. Both. All right, okay, let's go ahead and check the polls if this works at all. Any responses so far? How does that work? All right, so I'm getting a lot of A's and B's. Well, B's most likely. And yeah, let's go ahead and just flip back there to see what the actual solution is. Because in this case, it was, in fact, B. It was B. Yeah, so those that voted B on the right-hand side, that said AI was AI generated. You were, in fact, right. Yeah, so those that did say right. I mean, any ideas as to why or any signs? Feel free if you just want to shout it out.
It's too perfect. When I looked at them, I went for B. Because A, when you've got that light effect on the lens, people make, unless you're a professional photographer, most people will take a photo like that where B was too perfect.
It's too perfect. Isn't that funny? That something can be almost too convincing of what it is. Oh, let's just come on, pen. So I like what you said about the I think you're referring to this kind of glow, that this darkness that happens around the skirts of it. That's true. It feels more real, and that's why you told me that was more AI generated. Weird world we live in, huh? Honestly, I don't know what it is. Maybe like the paleness of the skin. Sometimes the kind of the focus. I honestly don't have the vocabulary to tell you. Like you said, I'm not a photographer. I can't tell. Sometimes with the hand, 1, 2, 3, 4, 5. Yeah, maybe. Like it's a bit of a weird. It's a bit blurry to tell apart, but definitely around the hand, I would say, what the hell's going on this? what is going on here? I think. Yeah. Oh, okay. So Dennis, if that's taking to register, I think there's no need to go ahead and do that. Okay. Well, I mean that's great. If you think you figured this one out, and just before we do move on though, any thoughts on A? Anyone want to jump on, or just feel free if you want to shout out, walk me through it if you want. It doesn't look real either, says Walita. Like this is kind of too forced sometimes. Yeah, it's got a few filters, sure. And what is a filter if not, a modification and editing somehow? Yeah. So it's interesting how we're comparing Muhammad saying this is too real, it's too convincing, whereas this is kind of overly fake, and we've sort of lived in the opposite world now. Weird. Okay, well, let's. I think I've got another one here. So if I propose that we consider now 2 images, I'm going to do this again. So if you're ready to put that to the test, then I'm going to propose that we consider now these next 2 images again. So the same code as above. I think, Dennis, if you wanted to use the same one again, that's fine. If you just need to hold your phone up, that's fine. But if you're okay with that, let me just send you the link so that we can have a look whilst we wait and check it out. So I'm not too sure what it looks like on your side, but I'll send the link over again just in case. What you'll see now on screen is 2 images. If I can, I believe it's the same link. Let me know. I see 2 votes, so I think it's probably the same one. All right, then let's blow up the image just to get people a better look. So which of these 2, left or right, was AI generated? Left or right this time? So it's a bit closer up. You can see more of the portrait. Okay, left or right? Left or right? Bad. I just didn't sleep too well. Let's check in with people. How are we doing? Oh, so we've gone for a even. All right, we've gone for an even split. AJ says A. Esperanza says right. Okay, all right. So we're losing ground. I think we're kind of splitting halfway through. Should we flip back? Okay, B. Well, the answer was, in fact, yeah, trick question. Again, no, Solita, you knew my mind. Well, yeah, so in fact, they were both AI. So most of you, I think everyone here was, in fact, right. In fact, so it is a lot closer at this point. Look, they are both not real people. They don't exist. The blurriness from B, it's almost like, I feel like we're losing image quality some places, but it's not detail that I think we're missing. It's really good. Yeah, they're too good. They're too pretty. So it's getting really hard indeed. But if you take a glance at this, really look up close, it's getting so good at this. In fact, this is already a bit old now. So it's only going to get better. And just to give you a taste of the images that we might see, now, or in fact, a bit further down the line. So the video I showed you at the beginning, in fact, came from, as you might have guessed, not real Tom Cruise. It came from deep Tom Cruise. So it's funny how he gets blue ticks for being an authentic user when his whole persona is to not be one, right? They're not real. This is the whole his streak to be a deep fake. It's really dark pen, so let me just change that up. So his channel is to be a deep fake. In fact, as you might have gleaned, was in fact not Tom Cruise. That was an example of a deep fake, which is a video which has been somewhat synthesized. If we, I'll come back to this website in a second. So what's a deep fake? If anyone has come across or seen or used or perhaps fallen privy to deep fakes. Hey, Ankel, no, I'm glad to see you. You're just right in time. No, at all. So what we're talking about is just the world of deepfakes more generally. So I showed you a video and we did a side-by-side comparison a moment ago. We're not really that able to tell them apart by the seams of things. And now we're getting to the point where videos are able to, or kind of images, put together to form a video, can be where a different human is going to be acting out those motions, saying those words, but software, artificial intelligence, inspired software, was mutating that actual image and more or less faking a video.
Democracy is a fragile thing, more fragile than you want to believe.
Yeah. All right, sure. So I guess this obviously was a faked video, which is all fun and games, I suppose. But as we start to tinker with these kind of examples,
Democracy.
Suffice it to say that we've begun to discuss it in workshops like today, and then of course misinformation that can be brought out from this kind of thing is only going to become more and more challenging in the world where it's not just text anymore, but it's also now imagery. And people on Facebook, they just gobble up anything. So all the more soon now, video is really going to take over by storm. So by today's focus, we'll focus more on the fundamentals, but what's enabling these technologies and the like. And actually more familiarly, before I forget, the text generation too. Whoopsie daisy. So this is also in a rage. Of course, it seems like a few months ago, probably everyone in this room started to hear about tools like ChatGPT and Anthropic and all the other ones too. So what I think is just do one last exercise together as a group, okay? So this is from another piece in the New York Times, which I love this, okay? So they asked the audience, they asked readers to vote in this thing, and they asked the question of, did a fourth grader, so I'm not American, I don't know how old they are, but essentially like a kid, okay? Did a fourth grader write this? Someone in year 4 write this? Or was it a new chatbot? Okay, you ready? So same as before. Another opportunity again, just to assess your discerning skills. I'll blow that up on screen if you want. So let's pop this in, shall we? Okay, number 3. Okay, sorry, I'm just gonna find the last one. Okay, so if you still have your link open, that's great. If not, I'll send it one more time. Sure. Now, so the question's not 9 to 10 years, not how old they are, but can you tell them apart? So you know that Who Wants to Be a Millionaire? Not Who Wants to Be a Millionaire, the other one. Are you smarter than a 10-year-old or whatever the show is? Well, this is what we're going to do. We're going to take another stab at 2 essays this time. So, okay, thank you. Got it. So as a 9 to 10-year-old versus a $1 trillion industry, can you tell the two apart? Okay. So which of these 2 essays, 1 or 2, was in fact written by AI? Okay, so essay 1 or essay 2, if you want to respond in the chat, we'll put that into the sheet we have. As folks will buzz in, I'll just read the first one. Okay, so essay number 1. I like to bring a yummy sandwich and a cold juice box for lunch, and sometimes I'll even pack a tasty piece of fruit or a bag, crunchy chips. As we eat, we chat and laugh and catch up on each other's day. All right, then. So essay number 2 is, my mother packs me a sandwich, a drink, a fruit, and a treat. Sorry, it's drawing on all the screen. When I get in the lunchroom, I find an empty table. I sit there, I eat my lunch, my friends come and sit down with me. Okay, so very, very similar. But what do you guys think? So obviously splits between 1 and 2s. Okay, so David and Watson's starting on 1. So feel free if you want to jump on, if you want to tell me or walk me through your process and your thoughts here, perhaps. 2 is best. So is it better written, or is it that it's more indicative of being a real person? So what are we saying? So I'm going by the crowd. I'm hearing both, which is so I'm just going to close my window because I have a neighbor who's playing the flute every single day at this time of day and drives me nuts. I used to love the flute. I thought, oh, how lovely. I've got a neighbor that plays the flute. Anyway, so what goes on is this one better written? Interesting, David. Yeah, so we're going for verbose, the verbosity. Do you want to pitch on that? Do you want to tell me more about what you might think?
It's the descriptive nature that I know AI tends to get a bit over descriptive in a lot of the things it does. I mean, S82 seemed a little bit formal for a 9 or 10-year-old, to be honest with you, in terms of the language.
Mm-hmm.
But SA1, I just don't see a 9 to 10-year-old talking that way. At least mine don't.
I absolutely agree with David. Do 10-year-olds still say yummy? I mean, I don't really know many 10 years old, but do people grown up for the vocabulary?
Yeah, I think you're right. I mean, yummy might be forgivable, but it's also so obvious, Another thing that I point out to, so what's quite obvious nowadays is, has anyone noticed like the overuse of the hyphen between words, like hyphen this and this and blah blah blah? You know what I mean? If you haven't yet, you will start to notice it everywhere.
Yeah, no, I've seen that too. When I generate CVs, I'll actually take the hyphens out.
It's so funny, right? Because I've always used the hyphen, and now I just take them out like you do as well, just to not be, even though it's a clearer, the use of it is helpful. It's kind of bad in our case. We don't see it in this case. I think we can forgive what happened before and after, But those are sort of syntactic clues. And I'll tell you another one, which is kind of more linguistic. Okay, so when we count things, often what's like a very effective rhetoric is to use triplets, right? To use things in threes: a sandwich, a drink, a fruit, and a treat. It kind of feels like sometimes it does insist on finding or pulling out three examples out of nothing. In that case, to be honest, I don't see that here. So as I say that, maybe that's a bad example. But yes, all eats. I think that's also as we eat. Maybe that goes into your point about being formal. You know, like think about a 10-year-old as we eat. What kind of 10-year-old would do that? Yeah. And we laugh and we catch up on each other's day. Like that shows a lot of gravitas that I just don't think they this is maybe more grounded in your point of view. My friends come and sit down with me, which is, I suppose, more realistic, right? It does sound splendid. It sounds too whimsical. I hate that sort of, uppity tone it picks up sometimes. Well, okay. I think most of us can probably see the cracks in that show. It was, in fact, numero uno. Yeah, this one was made by AI. But it's not too dissimilar from it. In fact, if we flip back to the answer, okay, so this one was written by a 10-year-old or a 9 to 10-year-old. Yeah. Old. Not world. So it's great to see that we already have this. We do have a discerning eye, even though it is not a perfect example. Sorry, just to chat that to one side. It's good that we can pick these things apart, but obviously, perhaps let me try to deflate that enthusiasm by saying it's only going to get harder and harder and harder just to discern one from the other. And now, really, we are on that bleeding edge of what's soon to be possible, and we're sort of over relying on these technologies as they come through. So, most everyone in this room probably by now has seen or tried or definitely heard of ChatGPT. But ChatGPT is all about textual, representation. An empty table. Yeah, the way that ChatGPT is, how it really works, I'll show you here. Okay, so it will respond to you with a system prompt that you're telling it to talk to me back like in the voice or the prose of a helpful AI agent who in this case is good at pretending to be a 10-year-old. And a 10-year-old is associated with things like school and, friends and all that stuff too. It's not perfect, but it is harder to get right now. Certainly within companies and more technical workshops too, they generally have been thinking about whether or not to use these kind of technologies, whereby we sort of deemed tools like ChatGPT in the current form just too helpful, too good sometimes. Sort of like an overzealous friend in school, right, who just wants to give you all the answers instead of just lending you them instead. So nowadays in like many higher education institutions, they simply just ban it outright. My sister is now in university and they've had this discussion, they've had a sit down talk where they just flat out prohibit all the use of AI-based software, such as ChatGPT and so on. Third-party tools like GitHub Copilot, Bing Chat, all that kind of stuff too. Anything that gives you or suggests or completes answers to questions or lines of code is sort of a staunch kind of no in many eyes. But it would seem reactionary to take away what technology surely has as well, with potential upsides too for education and other things too. And so what's beginning to evolve now is, the fair use and the permission for people to use AI-based software as an enhancement, which in fact we're going to go discuss now. So they're more or less built on top of these tools, ChatGPT, OpenAI, Microsoft, and beyond, and Amazon, of course. So companies are starting to use this, but in a way that where they've tempered the enthusiasm of what might otherwise have been a very or overly helpful model to more like a colleague or a chatbot, or more like a mentor or something that might be able to guide you with the answers, not simply just hand them outright. So what does that mean? In the context of schools, and the relevance to here, I suppose, is architecturally. For those with more engineering backgrounds, it might be curious to know how it's actually implemented. Okay, so if a student here in the classroom, perhaps, or just here, for example, if you raise your hand and you have a question, virtually in this case, they're somehow going to ask those questions via a kind of a central web application or the like. But in turn, we've built up much of our own logic, shall we say, on top of those third-party services known as APIs, okay, application programming interfaces. And there are features that other companies might provide to people like us in turn. Okay, so what they're really doing is these other parties, they're doing a lot of the heavy lifting for sure. And there are these so-called large language models, LLMs, that are out there. We too can have all this information that is not actually in the models itself. For instance, the words that just came out of my mouth, just last week, when we had a talk on last thing or whatever, or tomorrow, in fact, not to mention all the future conversations we might have that haven't happened yet. We really do sort of have our own vector database of sorts locally by which we can search for more recent information, then hand some of that information back into these models too. So, from a high level, architecturally, that's more or less the flow. I'll dig into this just in a bit, okay? But for now, I just thought I'd share at a high level first what it is that you and I and kind of others are familiar with, perhaps more with, and will be soon broadly available to our own employees online as well. So what we focus on really is generally what's known nowadays as prompt engineering, which isn't really a technical phrase because it's not so much engineering, okay? It's not really traditional engineering in that case. It is really just English, right? So what you're really largely doing is just giving the AI the personality that you want to be whatever it is you're looking for, giving it out what's known there as a system prompt nowadays, by which or whereby you give it some English sentences, send those English sentences out to OpenAI, you send it out to Microsoft, and that sort of teaches it how to behave. Not just using its own knowledge, its own vector database out of the box, but coercing it, if you want, just to behave a little bit more constructively to what you're trying to get out of this too. So we'll consider now more what's enabling those kind of tools, not just within kind of AWS too, within computer science as well, but really just the world more generally. What the whole world's been talking about, whether it is text or video or otherwise, is generative AI, AI that can generate images, that can generate text, that can generate or sort of mimic, the behavior, what we might think of as being human. What does that really mean? Well, if you start at the beginning, if you go back to the beginning, artificial intelligence is just a technique. It's a technology. It's a subject that's been with us for some time now, but it really was just the introduction of these very user-friendly interfaces known as chatbots, chat GPTs, okay? And then some of the more recent work and the widespread use of cloud hardware over the last 3, 4, 5 years or so really has allowed us to make a massive leap forward in terms of, it would seem, at least technologically, as to what these things can do now. But it's been with us for much longer. So what we do is we spin through the world of AI. I want to make this sort of entertaining enough, okay, just to show you that it has been with us for much, much longer than you think it is. Even though we really just started talking about it, recently. What is artificial intelligence? It's been with us for so long now, it's kind of hard to pin down. It's been so omnipresent that it's sort of taken nowadays for granted. But in the last couple of years, anyone who's been using Gmail or Outlook or whatever it is, okay, it's a technology that exists in emails, in spam filters. Okay, they're getting really good. It's pretty rare, at least with most big mail programs nowadays, where you have to manually delete spam. Okay, it's often just going straight to your spam folder. But there isn't some human, some person who works at Microsoft or Google who's looking at all your email or even all the mail coming in and saying, yep, not spam, spam, not spam, not spam. That just wouldn't be feasible nowadays. Okay, so somehow AI is inferring. It's a technology that kind of looks, it's a kind of technique. It's an algorithm, step-by-step instructions, if you will, just for solving problems. What is spam? What is not spam? Okay, it's not perfect, but hopefully it's usually correct. So Gmail, Outlook have been getting really good at spam detections. If you've not checked your spams for a while, just a testament again, just to how good it is and how they might seem as just getting it out in your inbox. Aside from that, you've also got things like handwriting technologies for some time now. So mine's terrible. But I guess it's only going to get better and better and better now. The more software is able to adapt to different styles of handwriting, such as this, right? So because no one at Microsoft, no one at Amazon knows you directly, doesn't know what your specific handwriting is. But it looks similar, though, to what other people have trained that AI with. So dare I say, en masse, and now it is. Also, too, we've got recommendation histories too. So recommendation engines. Where might we find that? Recommendation engines. Or what examples might you be able to think of? So I guarantee you've used one this week, maybe today. So anywhere where you might have something recommended or tailored for you specifically, and like, okay, so I mean, Amazon probably is just it's an algorithm backwards, shall I say? Amazon Prime certainly. If anyone's been using Amazon Prime for video or Netflix or any other service to music software like this, it's only getting better and better and better, recommending things to that you might like based on things that you previously had liked, that you've actually spent time or taken time out to like something or dislike something, or based on things that other people who like the same thing as you might have liked. Okay, so you might not know it yet, but you might like this, as they say. Instagram Reels are notoriously good for this. So if I just, it's obvious that no one at Instagram knows us personally. Just like, the old days of Blockbuster, where you might have a relationship with the person working at the counter who's actually recommending you things, specifically what kind of movies you might like because they see you every week. There's no code, there's no algorithm that says, if Chantel likes X, then recommend Y. Else recommend Z, because there's just too many Instagram, there's too many reels, there's too many people, there's too many different tastes in the world. So obviously it just works itself out. Okay, AI is increasingly sort of just looking for patterns that might not even be obvious to us, to humans, and dynamically figuring out what might be good for me or good for you or anyone else. So yeah, definitely Siri, Google, sorry for that, open up people's lives. Google Assistant or Alexa or any of those other voice recognition assistants that are just good at answering questions. Gosh, mine talks to me back all day long. I mean, they don't know my voice specifically, but it's pretty similar to other humans' voices. So they try to figure out how to respond to not only the Google and the Microsoft employees, but to yours and my voice as well. So that too, suffice to say, then, is all powered by AI. So I want to start with something a little bit, a little bit simpler, perhaps way down to the beginning, of course, of any of those applications. In fact, this is perhaps the simplest arcade game that anyone from yesteryear might be able to tell me in the chat what it might be. Four-letter word, starts with the letter P. It's sort of like a table tennis game. It's Pong. It's on like Donkey Kong. Okay, so the person on the left paddle here can move their paddle up and down with a joystick, and then the person on the right can do much the same. So the goal is here, like tennis, just to get the ball past that person, perhaps like an ice hockey table, in fact, or conversely make sure that your paddle actually comes and bounces back, right? Well, somewhat simpler than this, insofar as it can be just one player, is another game that was developed by Atari from, again, a long time ago. Anyone knows what this game was? Any video game antique nerds? It starts with a B. The game here starts with a B, BR, something OUT. One word. Well, the purpose of this game is similar to before, but Breakout was a game. Breakout, can't spell. Yeah, so with one player this time, developed by Atari, which was a good use case in this case because, I mean, you're essentially just trying to bang the ball up against these bricks, okay, just to get more and more of these points up above, and also just to try to break down and eliminate those bricks. But all of us in this room probably have some human instinct as to how to win this game, right? So all of us, at least how to play this game, okay? So, for instance, if a ball pictured here, like I tell you, is back in the 80s, like a single red dot just to the left of this, which is the paddle, okay? Where is the ball going to presumably go next? And then, and which turn, in which direction should I slide my paddle? Should I slide my paddle here to the left or should I go to the right? So this is the single ball there. Should I slide my paddle? Should I make it go left or should I make it go right? Yeah, Mohammed is left. I think presumably to the left, right? If I've just bounced it off somehow and then we all have an eye for what seemed to be the physics of that, then yeah, it would probably be left. So indeed, that's what maybe an algorithm also, or sort of step-by-step instructions for solving that problem might look like. So how can we translate that human intuition to what we might describe more as artificial intelligence? How can we translate that human intuition to describe what we describe as, not nearly as sophisticated as those other applications we just looked at before with the spam and the phones and other stuff too. But indeed, we'll just start with some basics, okay? So we might know maybe from economics or from computer science or things like that, okay? This idea of a decision tree. And that's a decision tree. It's just an idea that allows you to decide, should I go this way or should I go that way when it comes to making a decision? So kind of obvious, right? So just to consider how we might draw a picture. So if we think about how we might want to represent something as simplistic as we just saw with Breakout, okay? So if I ask you the question, if the ball is to the left of the paddle, this is a question or a Boolean expression, I might ask myself in code, whereby if I say yes, then I should move my paddle to the left, as most everyone just said. So else, if the ball is not left of the paddle, what do I do? Yeah, well, I actually want to ask a question there too. So I don't just want to instinctively go right. First of all, I want to go and check, is the ball to the right of the paddle? Why might that be? If anyone sees why might that be first? Any intuition as to why we might first ask this question? Just to check in. So if it's not to the left, rather than just presumably going or instinctively steering right, there might be a good fair chance something else. Okay, well, we'll circle back because if yes, if it is to the right of the paddle, then yes, of course, you want to go ahead and you want to move the paddle right. All right, so that's right. And there is that third situation, which I think David's just alluding to, which is, yeah, right. So if it is just above the paddle, what do you reckon, David? So what would be that third scenario here? What should we do, in fact? Kind of simple when you think about it. If it's not to the left, if it's not to the right, leave it alone, presumably. No, stop playing, which would be, it's not to the left of the paddle, it's not to the right of the paddle, it's probably coming straight down, isn't it? Yeah, so you just don't move the paddle, we just leave it alone. You got lucky, okay? So it's coming for you, for instance, straight to where you are. Perfect. So, I mean, Breakout is a fairly straightforward game when it comes to an algorithm, which is what you're looking at here, just a set of step-by-step instructions. And we can really translate a lot of this as a software developer now would be able to do into code. Or what we call here is more pseudo-code, if you will. So this is sort of English-like in that sense that it's removed or it's independent from Java or Python or C++ or any of those other programming languages out there, okay? This is English pseudocode, where it's literally written in English words and English language. So while the game is ongoing, if you understand what is happening, so if we're playing and if the ball is to the left of the paddle, I should move the paddle to the left. Or else, not threateningly, but the other tree there would be, if the ball is to the right of the paddle, it should say paddle, okay, that's a bug, not intended today, but move to the paddle, okay? Then move the paddle to the right. Or else, this sounds really ominous, but don't move the paddle, okay? So that again, too, just like we said, this translates or represents a translation of that intuition to code. If you think about this, it's a very deterministic thing. We can sort of anticipate ahead of time all the possible scenarios captured in code. And frankly, this should be, like a really boring game of Breakout because the paddle should just be able to perfectly play this game, okay? Assuming there's no variables, there's no randomness when it comes to speed or angles or the like, okay? Which, real world games will certainly try to introduce here. Okay, so we'll try to consider maybe another thing, then another game from, I don't know when in fact, but probably one that we do play still today, okay, and we maybe did growing up. So here is Tic-Tac-Toe, or Norton Crosses, okay, for those unfamiliar. The goal is for you to get three of a type, okay, 3 in a row, three zeros, 3 O's, or 3 X's in a row, either vertically, in any direction, in fact, okay, diagonally, horizontally, vertically. So suppose now I'm telling you, it's X's turn. So if you played Tic-Tac-Toe before, most of you might have a instinct as to where X should probably want to go so that it doesn't lose instantly. Where should X think about putting their turn? So just so that they don't have the immediate result of losing, Yeah, okay, middle left. Thank you. So, let's consider then a more general case. How do you solve tic-tac-toe? Frankly, if you're in the in the habit of losing tic-tac-toe an awful lot, okay, but you're not trying to lose tic-tac-toe, you're actually playing it wrong, because like you should minimally always try to at least force a tie in tic-tac-toe, and better yet, you should be able to beat the other person. So hopefully, everyone should walk away with this strategy tonight. So let's try to again borrow inspiration from the same decision tree and do something similar here again. So you, the player, you ask yourself, can I get 3 in a row this turn? Well, if yes, then you should probably go ahead and do that, because play the X in that position. That's a winner. Okay, that's a bingo. Play in that square in order for you to get 3 in a row. Straightforward. Easy peasy. So, this, it could be the bottom right, it could be in the bottom left. Whatever it is, you should always make the move that makes you get 3 in a row to win, essentially, and break out. But if you can't get 3 in a row, which might be more than often the case, if you can't get 3 in a row this turn, then you should ask yourself another question here represented in black. Okay, so can my opponent get 3 in a row their next turn? Because then, okay, if your opponent's about to be able to do that, you better preempt this by moving into that position, play in that square so that you can block that opponent's 3 in a row. Well, what if that's actually not the case then, right? So what if there aren't even that many X's or O's on the board? You're in the habit of just kind of playing it randomly. Like, you might not even be optimally playing if as good as an AI could, or if not, like, it's a kind of a question mark here. In fact, there's probably more to this tree, because we could think through, what if I go here? But wait a minute, like, what if I go there? Or what if I go here or there? You can start to think about a few steps ahead, as a computer should be, or could do much better than us as humans, because you can think much further. So, instance, for suppose then. So again, we're going to say it's O's turn. It's Pink's turn, shall we say, just for the sake of colours. It's Pink's turn now. So for those that aren't very, very versed in tic-tac-toe, I mean, you might have an instinct for where to go. So tell me if you want to. Where might you move if that's the case? What would be probably the gut feeling you might have in a situation? So Ankel says corner right. Maybe that's from a previous slide, because I think corner right's been occupied now. So you as Pink might want to think about the certain square. All right, okay. So there is this harder problem now, okay? It would seem that I can fit in 1, 2, 3, 4, 5, 6, 7, 8 different places if I'm Pink and it's my turn. But let's try to think about this a bit more algorithmically, okay? Let's try to think about this more like an AI might want to. And let's recognize too that, with games in particular are really good for this thing. Like, one of the reasons that AI was adopted in these early games early on, playing the CPU, is that games really lend themselves well to defining them, and if taking the fun out of it mathematically, defining them in terms of inputs and outputs. Maybe paddle moving left, moving right, ball going up and down. Okay, so you can really quantize at a very boring low level how to play the game. But that idea lends itself to solving the game optimally, in fact. So, in fact, with most games, the goal is just to try to maximize or maybe minimize some kind of a math function, okay? I mean, all sports have some kind of a number. If you really boil it down to its most basic form, yeah, my team scored 1 and yours scored 0, or we scored this and you scored that, okay? Most games have scores, they have numbers. And the goal is for you to maximize those numbers, maximize your score, or sometimes get a high score, a high watermark. So games really lend themselves, it's a nice translation then to maths, and in turn, AI solutions. That's why there was such an early field for this. So one of the first and the most obvious algorithm that you look at in AI is, if you look at a class of algorithms, if you went ahead and studied this more on AI more generally, is something called the Minimax. So this Minimax, it alludes to this idea of trying to minimize and or maximize something as your function, as your goal, okay? Try to minimize something and maximize something, hence Minimax. What does that look like? Well, it actually derives, I'm comfortable, from so it's inspired in some part from those same decision trees we've been talking about already. But first, okay, so let's look at the definition. So these are 3 representations on screen of tic-tac-toe boards. So on the left-hand side, okay, this is one that clearly green has won, winner, chicken dinner, per the green. Now, this is, well, again, another one here, which green has won, per the green. The middle one, this represents a draw. Now, there are a bunch of other ways that tic-tac-toe could end, but these are just 3 representative ones, okay? So a win, a loss, or a draw. But let's try to make tic-tac-toe a bit more boring than that might have struck you already. So let's propose then that this kind of configuration, this setup, should then carry a weight or a score. Let's say this one is a score of -1. So if O wins, that's a -1, it's -1. But if 1 wins, which I realize colors don't help here, but if X wins, then that's a +1. That's good. Okay, we're going up a notch. And if no one wins, we just call it even, 0. Okay, so now we need some way of talking about or reasoning about which of these outcomes is better than the other one. So what's simpler than 1 or 0 or -1? The goal is, of course, it would seem just to try to maximize this score, but the goal of O then is just to maximize its score, try to get -1. So X is trying to get +1, O is trying to get -1. That's the kind of direction you're putting out. Okay, so here we go. No one really wants 0. That's better than losing to the other person. It's the second best option, but suboptimal. Okay, but at least we have a way to define then what it means to actually win or to really lose. So now we can put this strategy into place. If you start to think like an AI now, just a quick check. Okay, so if I tell you then for an X to win was a +1, and for a, let's go for blue for no reason at all, for an O win, that's a -1. What would be the score on screen now, if you will? What would be the score now? So if I ask you what the score of this particular board is, just so everyone's on the same page, if we think about the strategy as a Minimax function, it's a +1. Exactly why? Because why? Yeah, well done, because I see we've gone up a notch, haven't we? One of those tres. Yeah. All right, so we got it. We're on the same page. So because X is 1, yellow is 1, and we stipulated arbitrarily, okay, whatever it is, that this just means that this board has a value of +1. Let's put that into a more interesting context then. So this is a game that's been played a few moves already. There's 2 spots left. No one has won yet, but supposing then it's blue's turn, O's turn. Now everyone probably has an instinct as to where they want to go, but just try to break this down a bit more algorithmically then. So what is the value of this board as it is right now? We actually don't know. We don't have a value. It's not even a 0, or perhaps let's say it's just kind of in limbo. So because no one has won yet, we can't give it a score right now, but we'll come back to that thought, okay? So just hang that question in the air, because what we consider then is what could happen next. So what we can do is try to draw this as a tree, a decision tree, just like as before. So on the left-hand side, if I say, so here, for instance, on the left, what might happen if 0 goes into the top left corner? Sorry, blue goes into the top left corner. I chose these colors really badly. And here's what might happen then if 0 goes to the bottom right middle spot instead. I've not thought the colors through at all, but hopefully you can see what I mean, okay? So there are sort of 2 outcomes for this. As O's turn, I could put it here, or I could put it there. Which one do I go for? Because if O's purpose in life is, blue's purpose is to try to minimize its score, it's going to go either left or it's going to go either right based on, well, which one has, or which one yields the smallest number, okay? -1 ideally. But we're still not sure yet because we don't have definitions for boards with holes in them like this, okay? We've just kind of not thought everything out. So what could happen next there? In that case, well, it's obviously going to be X's turn next. So now we hand it over. So if X moves, which unfortunately, okay, X or yellow, they won in this setup. Okay, so we can now conclude that in this case, if I'm playing as X, we can now conclude the value of this board is what number? And just try to forget the pink underneath there. That's bad on my side. Yeah, it's a +1. Exactly. Yeah, exactly, Mohammed. So you're right. We just give it a 1. Simple, straightforward, okay? Because there's only one real way for us to reach that board. And again, by transitivity now, you might as well think that the value of the previous board as what then? So if we can arrive at this one as being a 1, then this probably by transitivity is also 1 because no matter what, really, it's going to lead to the same outcome. It's a garden path. It's always going to go that way. So the value of this particular board, the one above, is actually yet still to be determined, TBD, because we don't know if O is actually going to want to go with the 1 over here, okay? And probably not, in fact, because that means if they click here, X wins, yellow wins. But let's see what the value of the board is. So suppose then that indeed X goes in the top left corner there. So if we put it in there, well, what's the value of this board instead? What's the value of this particular board down below instead? This is +1. So this particular board, there's no X's or zeros having 3 in a row. So what does that mean? What should be signing? 0. Yeah, exactly, Chantel. And you're right, because no one won, right? So the value of this board is only going to be 0, because there's only one logically way to get there. So we might also think about the one above that too, because that's the only way into this. The value of that board also to be 0. So now, if I ask you then, so what's the value of this board? If we started to think about the story by thinking about blue's turn, O's turn, blue's purpose is the min in Minimax. So then which move is blue going to make? Which is the ideal move in that? What play should we go? Should we go to the left or should we go to the right? You being the blue player in this case, of course. As you're trying to minimize that function, you're probably going to go ahead and choose the one on the right, because we'll try to make the one that, or subtract from your opponent's score, really just make the move that leads to this board here. Because even though blue can't win in this configuration, at least X didn't win. So it's minimized its score relatively, even though it's not a clean win, So, okay, I mean, this is all fine and good for a configuration of this board, and it's almost done, it's just over the line. There's only 2 moves left here, so it's not too hard to see. The game's about to end. But if you expand in your mind's eye, if you will, how did we even get to this branch of this decision tree? Obviously, some moves have been played ahead. So if we rewind then one step back, and where there's perhaps 3 possible moves now. And frankly, this decision tree is a lot bigger now. Okay, so if you rewind back in your mind's eye to maybe have 4 moves now, or 5 moves, or 9 moves, or whatever, imagine just zooming out and out and out and out and out further. This is becoming a massive tree of decisions. And even though this is that same subtree we just looked at, okay, a moment ago. This is the same decision tree we just looked at the previous slide, that exact same thing, but I just shrunk the font somewhat so it just appears on the screen there. On the right hand side, or what I point out on this side of the screen now. Sorry, my pen is not behaving the way I want it to. There we go. Okay, so on this side of the screen, we could have what happens if instead it's actually X's turn. So it's actually X's go because we're 1 move prior. Okay, there's a whole bunch of different moves X could actually now make too. So what's the implication of this? Well, most humans are not thinking through tic-tac-toe in this pattern. Okay, we're not thinking about this to this extreme, and frankly, like most of us probably just don't have the mental bandwidth to even think about going left and then right and then left and then right and then right. It's just not how people play tic-tac-toe. Like we're not just using that much memory, so to speak, in doing that. But a computer can handle this really well, and computers play tic-tac-toe optimally. So they're always going to choose the optimal path. So if you're beating a computer at tic-tac-toe, like it's either not implemented very well, or at least it's not following this very logical, deterministic Minimax algorithm. Okay, so this is now where AI is no longer just as simple as just doing what those decision trees have to say. Because in the context of tic-tac-toe, here's how we might have translated that just to code, or pseudocode, for example. So if the player is X, if you are this person, if blue, if player is X for each possible move, what I should do is calculate a score for that board. And as long as we're doing that verbally, and we choose the move with the high score, because X's goal, again, is just to try to maximize its own score. But if the player is O in that case, for each possible move, green, okay, for now, let's say calculate maybe again. So for every single move that could be, let's think about what the score is. Let's calculate the score for the board and then choose the move with the lowest score. So that's a distillation of that verbal walkthrough we just had, where we can think of this as being code, or at least pseudocode, where we can try to maximize our chances. But the problem with games is, well, not so much with tic-tac-toe, but more sophisticated games is this. Like we've seen tic-tac-toe, surely, noughts and crosses. But does anyone want to take a possible ballpark figure? How many possible ways there are to play tic-tac-toe? So like, paper, pencil, 2 human people. How many different ways do you think there are playing a game like that? How long do you think you could keep someone occupied playing tic-tac-toe in different ways? Any idea? And again, a ballpark figure. I'm not looking for an actual answer. I'm just saying, roughly speaking, how much do you think? What's your ballpark feeling? Well, there is a formula. And that formula is kind of hard to grasp here, but it must be all the different combinations, all the possible starts and finishes and endpoints, a fair few. And if you actually think that through, how big does that tree get? How many leaves are there on this decision tree, if you will? How many different directions can we take for that formula, right? And if you were thinking 200 or 250,000, not unlimited. Importantly or crucially, there is a limit, and it's 169. So that would be all the different variations or plays that could be done. So most of us in our lifetime, we probably haven't played tic-tac-toe that many times. I don't think there ever will be that many people who will. But just think about how many games you're missing out on. Okay, these are all the different decisions, all the different possibilities that you could have been making all these years. Okay, that's a really big number. That's a really big number. Okay, but honestly, that's not that big for a computer. 250,000 for a computer. Yeah, it's like a megabyte. That's like maybe a megabyte of memory tops, just to try to keep that in mind and implement that maybe in code in Java and C++ or something else. It's not that much memory, but yeah, okay. So 9 boxes, Chantal. Let's think about, do you know how many, same question then, for more complicated games. So all the games that you and I might play as we start to get more older, we start to gravitate towards chess. And if you only think about chess with played with only the first 4 moves, so played back and forth 4 times, so only the first 4 moves only, okay? So only 4 moves. I go, you go, I go, you go. It's not even a very long game. I think Scholar's Mate is like 4, 5, 6 moves. So less than you could even theoretically finish with. Anyone want to ballpark, how many different ways there are to begin, just to commence a game of chess with 4 moves back and forth? So quite a lot, with even just 9 options, right? A grid pattern like this. And what we're saying is 8, and then your opponent also has 8. Quite a lot more. A lot more than 9 boxes, surely. I'm not gonna stress you out trying to come up with a number, okay? But apparently why chess is so hard is that there are at least 288 million ways, just so that you can begin with, okay? Which is why when you're really, really good at chess, you are really good at chess, okay? Because apparently you either have an intuition or a mind for thinking about it. It would seem with so many more steps than your opponent would do. I love chess with the simple. It's a game where the question and the answer is staring at you at the same time, and it's just a case of who sees it. Has anyone heard of Go or seen the AlphaGo documentary? This is from 2021. It's an absolutely fascinating documentary, which I would absolutely recommend going. I wrote an article about this a while ago. I got really invested in this. Has anyone heard of Go or the AlphaGo documentary? So Dennis Hassabis, you'll probably see this face come about again and again. So Dennis Hassabis started a company called AlphaGo. And AlphaGo. What was his name? Lisa Dole, who was the famous player they played up against. So DeepMind is a AI company that served as it's owned by Alphabet, by Google. So they played a very famous game in 2016, 10 years ago now, where they beat Lisa Dole, a world champion in a 5-game match in a game of Go. I'm just checking, has anyone heard of Go, the game? It's really popular in South Korea and China, not so much in Europe. So where we thought chess was a complicated game, then the amount of combinations that you can do here are just staggering, absolutely crazy. Don't even get me started. So you've got about a good roughly 266 quintillion ways just to get through the first 4 moves only. Okay, so at this point, you at that point you just can't pull up your Mac, your phone, your PC, just to solve problems again like chess or Go or whatever it is, because you just don't have enough CPU, you don't have enough memory, you just don't have enough years in your lifespan just to have your computer crunch through all the numbers like that too. And thus was born a different form of AI, which was more about it was inspired by finding patterns more dynamically for this. Okay. And I think that'll be a good point just to have a little bit of a pause there, just to check if there's any questions, any thoughts, any queries before we go for a short break and we come back and we look at machine learning on the side of this too. I really recommend this. If you can tonight or this week perhaps, watch the documentary on AlphaGo. It's absolutely mind-boggling. It's on YouTube, I think, for free. There we go. There we go. One for the ages. All right. Well, I'll check in with you in a while. I think we typically go for a 10-minute break here. I'll make it a little bit less, in fact, just so we can get back and do some fun stuff on my back. Okay. I'll put a timer on if you don't mind. We'll come back in a few and we'll reconvene in a bit. Go get a cuppa. I'll see you in a sec. I think it's fine if I play this in the background, right? Should be fine.
I think they're gonna laugh. Everybody's gonna laugh.
뭐지? 아니 이거는 렉 걸린 것 같은데?
I don't really know what AlphaGo is trying to do here.
That's the understatement of the year.
Is it muff misclick?
Nope, that's the move. Aja Huang makes no misclicks. Isidol is very confused. These are not human moves.
This move also sort of inexplicable.
I mean, those you can clearly call those mistakes.
Yes, of course.
This is the first time in the 4 matches that we've seen moves like that.
Right. Oh, the value dropped even more.
It's weird.
We're like 45%.
White. I think white is winning.
Come on, Isidol.
That's unbelievable.
All right.
I was so confident that Moya would just be consolidated by black and that there was nothing there, and somehow he's just erased it all, like it's gone.
So he's found his weakness. That wedge move probably surprised him.
Yeah.
AlphaGo seemed to have such a good game, and then this whole sequence in the center sort of changed that.
He pulls off a miracle. He managed to make it so complicated that the artificial intelligence doesn't evaluate it correctly. I think it looks like Aja Huang, maybe sitting there, also knows that the game is over.
I can't not stop smiling. Did he smile?
No, I haven't seen him smile yet. I think he's still checking.
So serious.
He's so serious. He wants to be careful.
He concerns a lot. He really does his best. I think he feels something like responsibility or burden.
AlphaGo is too much like that.
Yeah. So it's percentage. The next move should be later. AlphaGo resigned.
Looks like AlphaGo is resigned.
Wow.
The most amazing game. I'm almost going to tear up. Was game 4, where he comes back and wins, right?
제 알파고의 패배의 순간 사람들이 환호를 했다라는 얘기를 들었는데 그 이유는 명확하죠. 약간의 무력감, 두려움. 아 정말 이렇게 우리 인간 나약한 존재였나. 제가 이김으로써 정말 아직은 지켜냈다고 생각이 드는 그런 순간이었을 수 있고 이제는 앞으로 인공지능 이기기 정말 힘들어지겠지만은 그래도 그 한 판을 이김으로써 충분하다. 이것으로 충분하다.
I heard from so many people saying, they were running out in the street. They were so happy. They were chanting, they're celebrating.
Especially after 0-3 down, at the time it seems to be hopeless that the end of the world is coming, but we see the light.
Usually, I'm happy when I win, not like my colleague wins. But this time, it felt like my win.
내가 생각한 대로 싫어가지고 일정에 막 이건데 끼우는 거 생각 못하다가 이건 해. 정말 이 정도일 거라고는 정말 생각도 못했어. 정말 믿을 수가 없었어. 믿을 수가 없어서 이거는 진짜. 예, 감사합니다. 마음 편을 이겼는데 이렇게 축하를 받아본 것도 처음인 것 같습니다. 이렇게 3연패를 당하고 1승을 하니까 이렇게 기쁠 수가 없습니다. 이 1승은 정말 그 전에 모았고 앞으로도 바꾸지 않을 정말 값어치로 매길 수 없는 그런 1승이 아닌가.
My question is about number 78 move. Chinese top goal player Gu Li said it was a God's play. What were you thinking when you made that play? Thank you.
그 수를 둔 이유는 그 수뿐이 없었습니다. 그 장면에서. 다른 수는 아무리 찾으려고 해도 보이지가 않아가지고 어쩔 수 없었던 한 수였는데 그렇게 칭찬을 받아서 오히려 좀 어리둥절합니다.
Does leave me a little bit in awe of the human brain's power, in particular Lee's amazing ability to cause AlphaGo problems and find something seemingly out of nothing. And so we really want to understand what had happened.
So it really was Lee's move. The key is the center. If the center go on, there's no chance. No, we were winning before this. But if AlphaGo thought it was winning and it couldn't convert that win, that means it wasn't actually winning. Otherwise, it would have had the right responses.
Would we have played it?
There was a steal in there.
What probability does it give it as white?
0.007%.
Is that in the position that he played?
That's when he played it.
I see. So we thought this was the one.
And also, the value is really low.
And so the God move was literally a God move because we believe that only 1 in 10,000 humans would have found that.
That's right. It doesn't come to mind as the top 5 in the top 5 moves.
And that's what Lee said. He said it was the only one.
And he thought it was the only one. Yeah, remarkable, isn't it?
Welcome back to the Four Seasons. World champion Lee Sedol went looking for AlphaGo's weakness in Game 4, and he found it today. Last round, he's looking to see if he can repeat that. We'll see what happens.
The place is a madhouse downstairs. Maybe as many, if not more, journalists here today than there were for Game 1.
We all were really excited for the 5th match to see what would happen. Was this going to be a 3-2 thing or was it going to be a 4-1 thing? And, there's a different message with both of those.
For me, I don't think AlphaGo will make the mistake again. But who knows? Maybe it will come in. And Lee Sedol have more confidence about this. Look like maybe Lee Sedol finds the key to open the AlphaGo.
오, 이거 돼요.
그러면 알파고가 착각을 했다 그럴 수도 있다 이거죠.
기대하셔도 좋을 것 같습니다.
You weren't crazy about the timing on this move.
Yeah.
And now you don't approve of this.
Yeah, I'm sort of thinking that maybe AlphaGo hasn't recovered from Game 4 yet. Yeah.
So
White has to do something about this idea. After
no, he doesn't play now. No, he needs to play that.
Him play some move is bad move. I feel something, maybe the weakness come back again.
Are we seeing another short circuit, or is there something,
I think it could be a kind of a misreading.
And you're pretty comfortable with saying that you're
looking good for Lee Sedol?
Good for Lee Sedol.
There's no reason for White to be playing that move. It's a bad move, and in some cases it's going to lose a point too.
It is exactly the same thing.
91% certain.
Someone was telling me that maybe it had more to do with neural networks, which I think is
The whole game, we thought that AlphaGo was wrong about the board position. We were super worried that, it's going to play garbage, it's going to be lose in a very embarrassing way. And this continued for the whole game. But this is a big deal.
When
did they play that?
Just now. So I don't know. I mean, it doesn't...
Well, that we don't know. We're not good enough go players to know that, right?
Yeah. As it turned out, none of us know Go well enough to accurately judge what AlphaGo is doing.
Oh, White is winning now.
This one looks like White is winning.
We all say some of AlphaGo moves are so weird and strange and maybe mistakes. But after a game is finished, we have to doubt ourselves, our judgment.
AlphaGo making another kind of nonsensical throw-in. We're not really sure what that's about.
This is what 10 or maybe 11 dot play looks like. It looks weird, and we don't quite understand it.
I think it is important to study more about AlphaGo's mistake, like moves, and maybe we can adjust our knowledge about.
Okay, well, let's see a big documentary. I'm going to leave an article I wrote about this in a message. Here's an article. An article I wrote. Gosh, I can't type. There we go. About that. If you do decide to go ahead and check out some stuff, I break down the history of AI in a bite-sized format, and I make some funnies along the way. Anyway, let's get back to this. So if you're with me, if you had a bit of a break, then where we were last at. Oh yeah, let's pick it up from here, shall we? Good stuff ahead. Hopefully you see now that this is really just trying to solve what is really complicated maths problems, just deterministic figures which, with enough time, memory, compute, and money really at the front of the problem, you can go ahead and figure this stuff out. A big field of history is going to talk about this for years to come. How when we first solved these challenges, Go being the biggest step, the biggest leap since then, probably has been Gen AI, and well, now we're in that age. Okay, we have born a different form of AI, which is more about finding patterns, which is learning from data, as opposed to being told by humans, this is what to do in this situation, that's what to do about then. Here is the code via which to solve this problem. So machine learning is different for a very, very, what's the word I'm looking for? It's not the same thing, is what I'm trying to get at, okay? Machine learning, ML, is a subset of artificial intelligence. Artificial intelligence, which has been with us since the 60s, well, machine learning is trying to get machines to learn themselves. They don't have to be spoon-fed the answer. They should be able to learn what they should do without being so, coached step by step, hold my hand, and, the way that we humans do. So, one way around this with reinforcement learning, which often goes by an acronym of reinforcement learning with human feedback, really cool subjects, for instance, which is one such example thereof, wherein with reinforcement learning, you sort of wait for the computer, or maybe you wait for a robot to maybe just get better and better and better at things. As it does that, you start to reward it with some pats on the back and say, well done, here's a reward function, have a cookie. Giving it a +1 every single time it does something well done, have a 1, okay? And then -1 if, or you punish it perhaps when it does something poorly. Again, a Minimax algorithm. So if you simply just write a program in, this AI or this robot, some just to maximize its score, never mind minimizing, just maximizing its score, ideally, it should be able to repeat behaviors. It did the thing well, okay, so it got a +1, it got a cookie. Good job, keep doing that, keep going. It should then start to decrease the frequency with which it does those bad behaviors that it got a negative one with. I'm starting to obsess with a game. This is super nerdy now, a tangent. It's called Trackmania. And I used to play it a lot as a kid growing up. Trackmania? Has anyone heard of or played or familiar with the game Trackmania? It really is just a time trailing game where you just drive a car, try to get through the course as quickly as possible. But it has become an unbelievably popular subject for AI experts. Anyone who's interested in machine learning I'd really recommend going and learning what advancements are being made here, because this is a breeding ground for this. Deepfakes has got nothing on this. The people who take this seriously, is a great video on that too. I really tried to do so many things I want to talk about, but I don't have the time for it. Okay, but anyway, if I just put that into chat, if you write a program like Trackmania did, which is just to play a game and then try to maximize, or rather minimize the time to get around the track, maximizing its score that way, you can reinforce that kind of learning and really try to exploit bugs in a track or the game, or kind of break physics, if you will. And this is where a demonstration, if someone wants to come up, which would be great, if by all means, if you wanted to come on, put your camera on, perhaps. I could ask someone if you want to put your camera on, or someone who thinks that they're not particularly coordinated, and this could be anyone as well, a handful of you. If you want to come up and just put your camera on, what I'm going to invite you to do is sort of like a game show here. I can't physically give you a pan or like a pancake or something pancakey, which is what I'm trying to do here. Charlie's with us, okay? So, Charlie, good to have you. Have you got your phone to hand, pal? Where are you? There you go. I see you scrambling. If you've got your phone, and this goes to anyone else, well, I'm going to ask you, Charlie, if you can, just to look around your desk, something that you can just try to imitate the motion as if to pretend it's a pancake, Ideally something like a phone.
Right.
And better yet, if something you're not in the habit of flipping too often, if you like to, just show me or teach me how to flip that object. So that when you get that gesture upwards, that phone or that thing should flip around as if you cooked on the other side. And we're going to reward you with a +1, Charlie. +1. +1. Pat on the back. Every single time you do that well. I'll give you a 0 there. 1, 1, 1. And look at this. Even within 5 or 6 attempts, I'm noticing you're getting less flick of the wrist, more flick of the wrist, less movement going on. That gesture upwards has gotten better as it's going on.
Yeah,
so more of this, more of that.
Yeah.
Well, I've got a really heavy phone, so I'm scared of dropping it and breaking the floor. But
thankfully, I've got a little charger, little charging brick that I can use.
Is it underneath the phone? It's one of those.
No, it's an actual just a brick, little USBs.
And mine's. I notice it gets a lot heavier the bigger the phone is, and the kind of thicker the weight of the case, right? But that's better.
What am I picking my phone for?
Just so that I can reward you with a verbal confirmation that you're doing a good job. And you are.
Positive reinforcements.
Yeah.
Are we doing AI stuff? I've literally just joined.
Yeah, you are. So this is the idea that we're going to give you a +1 as if to reward you verbally with a +1, +1, a +1. More of this. Do good job. essentially that's a round of applause, which you can see that's learning side, and actually a good example of an opportunity for reinforcement learning. Thank you, Charlie. I'll show you another example here of what I mean by reinforcement learning. And again, if you're a parent, if you've probably done this in some way, presumably with kids, younger cousins I've got, they try to get them to do more of one good behavior, ideally less of a bad behavior. How might you start to do this with code? Well, wonderfully, a researcher has been posting a video here, so I thought I'll share this. It's just a minute long, where we actually watch a robot go ahead and do exactly just this. So I'm going to go ahead and turn that volume down, screeching, just to give you a sense of what a human and the robot are trying to do together, okay? So this is the researcher, and the pancake kind of a bit similar there, okay? So the human is first going to try to train the robot. You see it's actually holding the hand and literally hand-holding, showing it a couple of gestures, get it rolling in that direction there first. There's no one right way to be able to do this. But the human seems to know pretty well the first time how to do it in this case. So it's trying to give the example of a good machine, how to do it successfully first. After a couple of trials, 5 or 10, okay, they're familiar. This is, Jolly got this faster, but, often you're in good company here where after 11 trials, there's a person picking up the pancake there. And, presumably there's a person behind this coding this up, in the sense that there is someone actually saying good job or bad job, +1 or -1, So after 20 trials here, you'll notice that here, though, the computer knows what it's doing, right? There's a mapping here to some kind of XYZ coordinate system where a robot can quantize what it's doing, Nice, look at that, okay? So to do more of one thing and then less of another thing. And you're seeing the virtualization in the background here, what it thinks is going on, those digitized movements going on. So after now 50 trials, 50 odd, the robot 2 has actually got it spot on finally. From going from nothing, the first walks, first steps now, it should be able to now repeat this again and again and again, just in order to go ahead and keep flipping that pancake in the far future. And we'll see then over time, as we move forward, as we reward more, as we reinforce good behavior, the better, even a robot controlled by software nowadays, where we can get over time without being programmed to move up or down, left or right, but just try movements that do more of the good, more of the good stuff and then less of the bad stuff. So, this is what we call reinforcement learning. YouTube, get out. In the sense that you're reinforcing the behavior or you're kind of negative reinforcement, that too. Very Pavlovian in that case. So here's another example I just wanted to bring up, just to wind back to games for a second, like we said before, but in a very abstract way to begin with, okay? So if you're playing a game like, The Floor is Lava, if you're familiar with, presumably anyone with siblings on the sofa knows, where you're really only just supposed to step certain places so that you don't fall straight in the lava pit or something like that, okay? You lose a point, you lose life, something like that, okay? So each of these squares here in red, they might represent a position. So this yellow dot, this Pac-Man figure, should we say, that represents you, the human player, the person that can go up, it can go, well, not left, but up and left and right and down usually, within this world, within this 4x5 grid. So I'm just showing you the whole, I'm revealing to you where those lava pits are, okay? So you now know that it's here, here, and here, but the goal is, at least for the yellow dots here, in its own little box, in any good game, as in any good game, it doesn't have this bird's eye view, and it doesn't know from the get-go exactly where to go. It really is just looking at 4 empty walls, okay? It doesn't have any heat signatures. It's going to have to try some trial and error. There's no getting around this too. But if we, as programmers, as software developers, we might try to reinforce good behavior or punish bad behavior, we can teach this Pac-Man yellow dot without giving it step-by-step instructions, up, down, left, right, and the like, what behaviors to repeat and what behaviors not to repeat. So, for instance, let's suppose that the robot moves first of all right, and then, okay, well, that was just bad. Clearly, the very first move in life, straight to the alligator's mouth. Okay, you fell in the lava already, that was a bad move. So what we'll do is we'll set aside a bit of computer memory, so to speak. We'll just draw like this thick red line on the wall here. Don't do this again. Bad. Slap on the wrist. -1, so to speak. Okay, so maybe now this time, with this in mind, the yellow dot moves up this time. And we can reward this behavior by not drawing any walls or essentially just allowing that to go again, which it does, and it makes pretty good progress. So it goes 1 more to the right this time, and then look, damn it again. So it took a right again and then fell into the pit of lava 1 more time. So let's use a bit more computer memory this time, okay? So just keeping the heap alive. Okay, we're just going to keep track of, okay, don't do this thing anymore. Next. So now the next time the human or the dog goes this way, all right, okay, not good either. We want to punish that particular behavior going up at this particular square. So we'll remember that much again, you bet, with that red line. All right, so we're kind of paving the walls with red, shall we say. But now we're starting to make real progress. Until... yeah. Okay. We stumbled into that one right there. But eventually, even though that yellow dot, much just like our human, but just like Charlie with his phone and the pancake flipping robot, had to try again and tried again and again and again, and really just after enough trials, after enough trial and error, it's going to start to realize what behaviors it should repeat and which ones it shouldn't do. And though in this case it might, finally makes its way up to the green dots. Hey, it got there. Reward. Okay. So again, just to recap, once it finds that path, now it can remember in green. It can remember that forever. It can entrench that idea with those green thicker lines, that +1 behavior. So anytime that you want to leave this map, anytime that you get a really good at a game or something, you just follow that same path again, that same figure. So you don't fall into the pit of lava here or there, But just like an astute human observer might realize, yeah, this is correct. It's getting out of the so-called maze, but what is suboptimal? What is bad about this particular solution? You know, we've got there, we've won, but is it perfect? What is suboptimal? So knowing what we now know about the Minimax algorithm, any thoughts, any suggestions to our human player or our yellow dot about arriving to the green? Think about it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The other way, yeah, Chantel. So presumably then there is another way, perhaps a better way. And what might be better about the other way? Or suboptimal about this way? Because it works after all. Again, if we want to really think about this as a mini-max, or just to maximize one's own function, presumably the less moves made, the better, right? We want to stay on those lines and get there faster. So I think there is a better way. And I think, to put words in your mouth, Chantel, it's taking a really long time. You know, there are more efficient ways to get there. 6, in fact. So almost half, 1, 2, 3, 4, 5, 6, yeah. It's taking a really long time. It's inefficient, you know, but because I say, well, if we just try another way around this, you know, different path occasionally, maybe we could get lucky and maybe we could get to the exit a bit quicker. We could get there in 6 steps or less. And maybe that means, yeah, we get a higher score, we get rewarded even more, we get a bigger cookie this time. So within a lot of artificial intelligence, you know, a lot of those algorithms, they make exceptions for stuff. There is this idea within AI of exploiting versus exploring, whereby, you know, you should occasionally say, yeah, you know what, exploit the knowledge you already have, and frequently exploit that knowledge too, explore that knowledge. But occasionally, you know, you know what you probably should do. You should do it this way, you should go that way, but let's just take it a bit further. Let's just push the boat out that way, just in case. You know, let's take a left instead of a right and just see if it leads you to the solution even more quickly. What if, you know, what if that curiosity leads you maximally better? So you might find a bigger and a better solution. So mathematically, if you want to think of it like this, then if I so 10% of the time, okay, epsilon here, as I say with epsilon, this is obviously pseudocode, it's not really, just some variable thereof, okay? So epsilon, sort of a sprinkling of salt into the algorithm here, okay? And epsilon will be like 10% of the time. So if my robot or my player, if they pick a random number that's, say, less than 10%, you know, that's going to make a random move. By the way, this is how AI difficulty works. You know, you play a game, it says like play on easy, medium, hard mode. You know, this is the choices made by those AIs. You know, it's how often it makes those random moves. Go left instead of right. Even if you typically really go right. Otherwise, you know, guys, let's make the move with the highest number, you know, as we've learned over time. Let's try to always choose the highest value. So what the robot might learn then is, you know, is actually we could go via Chantel's path instead. We could go, presumably, well, we could go this way too. And that way is going to get us to the output faster. Yeah, rather than going down and, you know, right and then up again, we could get a higher score. We could do this in less time. It's a win-win. Yeah. So the robot might learn this and do it in a way via this path, which gets us to the output faster. And, you know, of course, we get a higher score. You know, big hooray. Okay, we do it in less time. Win-win. Frankly, this really resonates with me too, because I've been in the habit, really, as maybe some of you are as well, when you go to a restaurant perhaps, and or just a place that you really, really like to eat, and you just find a dish that you really vibe with. You know, I will never again know what other dishes in that restaurant offers, because I'm optimally happy with the dish I've chosen. I'm happy with that dish. I always choose it. I'm really happy with it, okay? You know, I will never know if there's actually even a better dish out there at that restaurant again, unless, you know, I sort of sprinkle in a bit of epsilon, you know, a little bit of randomness here and there into my game, playing it, into my dining out experience, and I try something else for a change. The catch is, of course, though, that I might be punished, you know? I might therefore be less happy if I choose something I didn't like it. You know, I should have gone for the thing I knew I liked best, okay? So there is really this tension between exploring and exploiting, but in general, computer science, and especially in AI, adding a bit of sprinkle of randomness into this, especially over time, can in fact give you better and better results and better outcomes still. But now there's this notion of more deep learning, whereby with deep learning, what you're trying to infer is to detect patterns, try to figure out how to solve problems, even if the AI has never really seen those problems before, even if there's no human there to reinforce and say, yes, well done, or bad behavior. You know, maybe it's just too complex. It's too wishy-washy. It's too much of a thing for a problem to even stand alongside a robot and say, good job or bad job. Okay, it's just too the space age stuff. And so within deep learning, there's another subset of that called, well, very much related to what you might know and think of as being neural networks. And neural networks are, again, inspired by the human physiology, a very, very human-inspired idea, okay, where inside of our brains, instead of elsewhere in our body, there's lots and lots of these neurons, okay, these things here depicted, and these things, they send electrical signals to make movements happen from your brain to your extremities, okay? That's carried alongside with electricity, and then your biochemistry might allow two of these via which signals can be transmitted over a larger distance. And of course, computer scientists have drawn inspiration from these body neurons, the things that exist in your brain, okay, to create that in software, that replicate that idea into what we now call a neural network. And so obviously that's better explained as, or pictorially, as like, you know, whereby there's just inputs to those networks and there's outputs from those networks too. And when we start to get more space age and we have more of them, we might think of them as being a collective brain, but really these things just represent inputs to problems and then solutions there too, outputs of that, okay? So if you just allow me to abstract away the more biological diagrams for these circles, if you just think of them as being nodes in a network, okay, things that just represent nodes or neurons in this case, This is on the left what we'd call an input in machine learning, and then that would be called an output. Again, this is really simplistic, very, very simple, literally the most simple neural network I can think of, where there's just two. This might be a bit more common now, whereby the network or the AI is going to take not one, but two inputs to a problem and tries to give you out one solution. Okay? Just to make this a bit more real for you. So for instance, let's suppose then that just for the sake of discussion, that here is a grid that you might see kind of in maths, and where the y-axis and the x-axis, so vertically, horizontally. Suppose then there is a blue and a red dot in the world. Suppose then that our goal, computationally, is to predict whether a dot is going to be blue or is going to be red, just based on its position, based on that coordinate system. Okay, so, and this might represent some real world notion, maybe it's something like, is it raining, is it not raining, something that we're trying to predict, okay? So right now we're just doing it more simply with colors right now, but you can imagine this being applicable elsewhere in life, okay? So just if I think about this as my y-axis and my x-axis, and effectively, my neural network, you can conceptually think of this like this, okay? Some kind of implementation of software whereby there is two inputs to the problem, x and y, so give me an x, give me a y value, and this neural network will output a red or a blue as its prediction. It will predict either a blue or a red, rain or not rain, good or bad, whatever it is. Well, how does it know? How does this know whether it predicts red or blue? Especially like if no person has ever painstakingly gone and written code up and then done the decision trees to say whether you see a blue dot here or conclude it's red there. How can an AI, how can machine learning just dynamically learn to solve problems? Okay, how does a machine learn? Well, what might be a reasonable heuristic here? And this is probably I know machine learning 101, but the first approximation that's going to be pretty good. Okay, so what I might say is I'll draw a line down the middle and say that anything to the left of this line, let the neural network conclude that this is going to be blue. Okay, and if it's to the right of this line, then that's going to be red. Sure. Okay, so until such time as there's more training data, that there's more real world data that's going to give us to rethink this model or rethink our assumptions, that's pretty good. If it's on this side, it's blue. If it's on that side, let us predict it's red. So for instance, okay, there's a third dot here. Well, clearly, we break our rule now, because clearly a straight line is a linear algorithm is no longer sufficient, shall we say? Okay, so this is called linear regression, by the way. So maybe it's more of a diagonal line that splits the red dot from the blue dot there. Okay, maybe we can find a better angle, and indeed we have found one here, fortunately enough. Meanwhile, a bit further down the line, let's imagine there's more dots, but it's actually getting a lot harder now. Like this line is still pretty good, the one in white, okay? So most of the blue is up here on the left-hand side, or kind of top left. Most of the red is down there, and we can talk about fancy algorithms to help us approximate this stuff. But, if we fast forward to today, like AI is often very good, but it's not perfect at solving problems. But what it is that we're looking at here is, what is it that this particular neural network is really trying to figure out? Well, at the risk of taking some fun out of the blue and the red dots, you can think of this neural network as just having these input neurons, which represent, things going into a machine, or ideas being weights, shall we say, weights going into this black box, and then outputs coming out of this, prediction, okay? And then what's really going to happen inside the computer's memory, it's trying to figure out, well, what the weight of this arrow or this edge should be, what the weight of this arrow should be, okay? What the weight of B might be. So, and maybe there's another variable there too. Maybe there's plus or minus C that just kind of tweaks the prediction, adds a bit of salting in there into the mix. And so X and Y are literally just going to be numbers in the scenario. We call them weights in a vector database. So the output of the neural network ideally is just going to be basically blue or red, okay? True or false, yes or no, left or right. Is it good? Is it bad? Binary states, that kind of a decision tree. So here too, just to take the fun out of it, the pretty picture one more time, it's a bit like a math function, but hopefully you can see that now. Well, what the neural network is, what we just saw trying to figure out then is this is the formula of that form, okay? So AX plus BY plus C, which is going to be some arbitrarily greater than 0. And so let's conclude then that the dot is going to be, let's imagine it's going to be red then, blue maybe. It's going to be red if it's a positive result. And if you don't, let's conclude that it's, let's go for green, why not? That is going to be a negative result instead, okay? Or the opposite. So what you're really trying to do or figure out then is try to dynamically figure out what numbers we do have to tweak, what weights, what parameters inside the neural network, just tip it over this way or give us the answer that we want based on all this data. And if you can follow what I'm saying then, more generally is when we start to represent deep learning. It's not as simple as, input, output, input, output. There's actually a lot of these nodes, okay? A lot of these neurons. And what you're looking at here is not even that complicated, but where we hear these doomsdayer stories of we don't know what AI is and how it works and all this other kind of scary new stuff. I mean, what they're literally saying is it's such a mesh, it's such a spaghetti of neurons and deep learning that it's hard to extrapolate. We don't really know how it works, but we do understand it. We just don't know. We can't trace the outlines, so to speak. It's not as scary as it sounds. Okay, there's a lot of these edges that you can see, and they exponentially grow. And there's a lot of numbers and a lot of maths, a lot of these feed-forward algorithms. So frankly, even the computer scientists using these neural networks, they don't necessarily know what they mean or what they represent, but they just happen to be this. They just happen to lean this way. When you crunch all the numbers with all the parameters in place, you get the answer that you would, the one that you want. Okay, at least most of that time. So essentially, that's essentially the intuition behind deep learning. You can apply that to a very real world. If mundane applications like this, like weather forecasting, given today's humidity, with that in mind, given X with this as well, today's pressure, yes or no, should there be rainfall? Should it rain? Maybe there's some kind of mathematical function based on the years and the years and the years of training data that it previously knows. We can then infer, hence, you see this often as an inference, what that prediction should be. It can infer this. Okay, another one, for example. So given this amount of advertising this month, what should our sales be for that month? Should it be up or should it be down or something else? So real world problems, they map readily when you can break them down into those inputs and binary output more often, or some kind of output where you want to use the thing to figure out based on past data what its future prediction might be and infer from that too. So that brings us back to generative artificial intelligence. Generative, which isn't just about solving problems anymore, but really literally generating images, generating text, generating videos again, that increasingly resemble what we humans, we might otherwise output ourselves, and sometimes better. So within the world of generative artificial intelligence, of course, we do have those images that we saw before. We saw the same text that we saw earlier, and more generally things like ChatGPT, which are really good examples of what we now call a large language model, an LLM. And these sort of massive neural networks, which have so many inputs and so many neurons all intermeshed and interpreted in software, essentially they represent all of the patterns and all the software that has been discovered by being fed a massive amounts of inputs. Think of it like taking the entire textual content of the internet, all of human knowledge, and then the entire content of knowledge that might be out there on the internet, okay, and then books and even though these AIs, these large language models, they haven't necessarily been told how to behave. They're really just inferring from all those examples, the whole human corpus, for better or worse, how to make those predictions. So this is a seminal paper, again, from 2017, just a few years back. So Google researchers put this out there. You will hear this mentioned in textbooks and kind of history books in the future, okay? Google introduced what we now know as the attention is all you need paper, and this is what devised the transformer model, okay? So what they got at was a transformer architecture. And this introduced the... it's called attention is all you need, even though it is really just about translation. But it does grasp this idea of lending attention to things. And I think attention is a good word. It's a good way of putting it. Like you're trying to lend attention values, literally lending attention to things more than others. Where what they did is they proposed that in a, if I have time, I'll show you this a bit better, like the transformer architecture. Maybe I'll show you because we've got a few minutes left. Any other human sentence really, where you try to assign numbers. Not unlike our past exercise we've seen already, to each of those words, you take each of those inputs that we just saw in our neurons, and each of those inputs is going to speak to its relationship, how it relates, how it soaks in the context to other words around it. It's like being aware of its surroundings. If I just find, so sequence to sequence vector, it's probably a bit of a blurry description, okay, but maybe Amazon say it best. I'm just going to go and get their article, okay? So if there is a relationship between two words in a sentence, okay, so transformers are a type of neural network that transforms changes an input sequence into an output sequence. They do this by learning context and tracking relationships between things and sequence components between different parameters. For example, what's the color of the sky? Well, the transformer model uses an internal mathematical representation. It knows in its own mind, the relevancy, the relationship between the words, the color, the sky, blue. Those words are mathematically closer than the word what, so sky and blue are mathematically closer than the word what and off, maybe, or what and color. So, obviously oversimplifying here, but there is a relationship where we have, this is what the vector database is. It's just going to give a high attention value to this. Maybe it's a preposition, maybe it's an article, maybe it's, the or the like, or maybe those attention values are a bit lower. So, I think I've got an example here. Okay, so this is what I did before. So the first step in a transform model is first going to encode words. We call this encoding. Embeddings are the kind of process of this, but encoding and decoding. So feed forward, encode. Okay, so you use an encoder-decoder architecture. The encoder reads and processes the entire input data sequence, like an English sentence, and transforms that into a compact, into mass, okay, like this grid or this vector database, or this vector slice, this formula. So this representation is that summary that captures the essence of that input. I know that's kind of hard. It sounds a bit abstract, but it is that, okay? It literally is this, okay? The decoder takes that summary and step by step generates the output sequence, which could be the same sentence translated into French. The original purpose was that as a translator, that's what the architecture was initially, but soon became something else. So, for instance, if I tell you this, okay, encoding in that world means that we start to begin to detect patterns and we start to predict things, you know, like autocomplete, like words, that is, generate text. So, for instance, a few years ago, completing this kind of a sentence was actually pretty hard for a lot of AIs. You know, for instance, Manchester, which is a major city in the northwest of England, okay, rich industrial heritage. The city's 18th century canal system records a city's days as a textile powerhouse. Okay, so Now, you might think this is pretty straightforward. You and I, as humans, can, you know, make out what's going on here. It's like giving you a softball kind of question. What's going to happen next? Historically, though, within the world of AI, you know, in this word, city, was relatively quite far away from the proper noun that it was actually referring to originally. So we just didn't have computational models that took in a holistic picture. And frankly, the way that we humans are much better at, in fact. So if you ask this question a little bit more quickly, you know, a little bit more immediately, you might have gotten a better response. But this is, I dare say, why chatbots in the past have been just so you know, they've been very stilted and often just used in the world of customer service and the like, because they're not really taking the whole context into account that, you know, that we humans might be inclined to produce. So what's going on underneath there? Without escalating things too quickly, so artificial intelligence nowadays, those LLMs, those large language models, what they might do is they might encode the entire input. Okay, so you type into ChatGPT, blah, 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 you ask a question, you say whatever you need to do, and then it's going to break down your user inputs. Again, your input goes into the feed-forward algorithm, into the machine, okay? Your ChatGPT is going to break down your user prompt into individual words or tokens. So it's going to break them down. We might take into account then things like the order of those words. Okay, Manchester is a city, blah, 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 blah. Okay, so Manchester is first, a century is last, that kind of thing. The order might come into this. And then you might then further encode those inputs using a very standard way. And there's many algorithms for doing this. I'm not, you know, sequenced many ways of doing this, okay? But you can come up with something that's just known as an embedding. Okay, so what we have then is a way of getting those into an embedding, which is to say then that we can take something like words or images or kind of any kind of input really, and end up with an embedding, which is just going to be a mathematical summary of that. Okay, which is to say then that you can use any of those APIs I talked about at the beginning of this, okay, or even software that's running on your own computers, just to come up with mathematical representations, just to encode something into an embedding of, say, the word Manchester. And so this almost killed me, but this is the 1,000 odd, you know, floating point values that OpenAI uses to represent the word Manchester. Okay, which is to say then that you should not understand anything from looking at the screen. Okay, this should be absolutely gobbledygook, which is when people say we don't know how AI works. Nor should you. I mean, look at this thing. Yeah, it's just a mathematical representation of what you and I think of. The same way that you and I don't think of. We don't think in terms of light signals and electricity. We think of in terms of, you know, abstractions based on this too. This is no different. Okay, this is just a representation of the inputs compared against the mathematical relationships of other inputs. And we're trying to find proximity, closeness, semantically, how close they are. You know, words that somehow have relationships that gravitate to each other or correlates to each other in a way that help ultimately the AI predict what the next word should be out of its mouth, so to speak. So in the case like this, you know, these values, these lines, they represent all those attention values. And see, these are, I've drawn here as like thicker lines. So these thicker lines, when they're thicker, it gives up, there's more attention there. Okay, there's more attention given from one word to the other. So 18th century has more attention than say A and city. See, that's a slightly thinner line. Okay, so thinner lines mean the opposite in that case, and that's how these are embedded. Okay, all those inputs ultimately are going to be fed into a large language model where you have sort of input on the left and then output on the right, and then in this particular case, okay, my hope is just to try to get out a single word, which is the name of the city itself. You know, where somehow, okay, the neural network. And the people behind it, OpenAI, Bedrock, and everything else, okay, Microsoft and Google or elsewhere, they sort of crunch the many numbers again and again and again by training those models in such a way on so much data that it now figures out what all those weights are. It has a worldview, which is a bit of I hesitate to say the word, but it knows what the world is. Okay, you know, it understands biases, it understands attention, it knows how to influence mathematically the output thereof. That said, it's not perfect. Okay. And a transformer literally is so where the transformer algorithm originally the transformer model, the T in GPT, generative pre-trained transformer. There is a lot of pre-training going on to establish those biases to understand where the weights are those distributions. It's crunched so many numbers that it's essentially pre-trained. It's like you have a brain, but it's like it's a good brain. It's got 90 IQ. But if you want to train that further, if you want to get a custom GPT or make it a useful GPT or make it a large language model that's good for a particular use case, you basically make it do something, or you give it a bit more intelligence, so to speak. Foundational models are plenty. We've got up the wazoo. There's so many of them. In fact, they're open source now. So kind of the AI race scrambled to be the first to get there, and now it's a dime a dozen. You've got so many foundational models to choose from, and different biases underneath them all. But large language models are to some extent closed source, where we don't know how they figured out its prose, its tone. I don't know if you've been used a lot. Like OpenAI is in hot water recently because of it's very syncopancy. I don't know how to pronounce that word. Like someone who always, like a yes man. Let's find this. So OpenAI, ChatGPT, syncopant. I've never said the word aloud. I've written it before. Syncophony. Psychophony. Is this maybe you've come across this? Okay, it's in the news a lot because they like all this. You're absolutely right. 100%. I'm with you. I'm behind you. All this BS that it keeps pouring out, it's really bad. Like this is not something we want to have in our lives because it encourages, mental disorders. It produces a lot of bad behaviors in society. Okay, but you have people like, let's go and find that article. There's one I was reading about. Of course, I just bloody closed my browser. 1 second. Let me just go back to where I was. Oh, I closed the tabs. It's really annoying. So ChatGPT. I believe I am a prophet. I'm looking for a particular post that came about last week. Yeah. I mean, this will speak for itself. Yeah, so okay. No. Oh, where is it? Bumbling something. It was really funny. Like it basically just said the person was an idiot, but I believed them. I can't find it. Sorry. I'm looking for a particular funny conversation that got them into a bit of trouble because it proves them that it doesn't matter. But to your question more formally, the transformer architecture, it may be something I'm going to spend a day on. I think maybe next week, if I can come back and do another lecture, if that's okay with people off top, I'll have to come on and talk actually how this works, what this looks like, because it's quite hard to grasp. Ultimately, what you're trying to do is feed forward a lot of those inputs into a large language model, where those inputs can be then producing, auto-predict, basically influencing the next most likely word for this. It doesn't know anything, but it knows with some probability that it's going to come next. That means that it's not perfect, because with probabilities, they never are. And so for the longest time, it was all the rage there with hallucinations. And I'm just trying to find... Yeah, I'll send this link over. Maybe that's going to explain this better. So softmax was how we produce the embeddings. Recurrent neural networks. Convolutional neural networks. Yeah, so they've trained all the large corpus of data, all the human knowledge in the world, which means that they predict the next value in a sequence based on all the preceding values. It's like the Fibonacci sequence, okay? 1, 2, 3, 5, 7, etc. By using more than 175 billion parameters. So that's what makes that large language model so large, and what makes it different from useful, in fact, that it has those weights in so many dimensions that we can't even imagine what it looks like. You and I think in like 3D models, 4D if you're going to those fancy cinemas. Imagine thinking of 175 billion D. It's just insane how much you think of. It sounds very confident a lot of the time, but sometimes it just makes stuff up, because of course it doesn't know anything. It's just thinking about the next likely thing. It's just pulling something out of the hat and saying, yeah, that's probably the next word. And of course you can call it out sometimes and say, that's not right. I don't like this. I'm going to negatively enforce this. And that's why you should always say thumbs down or thumbs up in your conversations with ChatGPT. It will plainly just apologize and say, oh, I'm sorry, but it made up some statement. It hallucinated because it was so probabilistically thinking that something can be said, even though it's not correct. It's still, that's what it could potentially be, It's like saying, who's the next Prime Minister of the UK? Like, it doesn't know, but it might say something along the lines of what might be most likely. So this is something that's going to become less and less frequent, hallucinations. So because models now evolve and kind of our techniques evolve for this around too, how to get around that idea, this will be less of an issue. But I thought just as content o'clock, so I'll just finish on a fun note that I came across, which is an old poem by Shel Silverstein. So another something from our past, maybe, perhaps. And this was from a poem called The Homework Machine. So this is maybe foretold where we are now in 2025, okay? So 1981, the homework machine, oh, the homework machine. The most perfect contraption that's ever been seen. Just put in your homework, then drop in a dime, snap on the switch, and in 10 seconds time, your homework comes out quick and clean as can be. Here it is, 9 plus 4, and the answer is 3. 3? Oh me. I guess it's not as perfect as I thought it would be. Quite foretelling indeed. So that's hallucinations in a nutshell, but we're getting better at them. For all that being said, I'll post in a couple of fun links that I'm gonna... oh yeah, this is why I should have closed all those links from before.
Each of these cards...
I would recommend definitely going and read, watching that documentary if you can. I posted a link, an article that I wrote myself a while ago in the browser if that's of interest to you, which I will just selfishly repeat in the chat for those that are with me. It's a Friday night and I don't want to keep you behind. Unfortunately, I have to be up and early tomorrow morning because of security engineering. So if anyone is with me tomorrow, I'm not sure, I can't remember names, but I will be with you tomorrow for a bit of security engineering. It will be fun. How does this work again? I can't remember. Anyway, we'll talk about this much soon. I'll put it in so we can maybe have another go next week, so we can maybe look at the transformer architecture a bit closely. It's a really fun one to look at, and all the more and more rage nowadays. Okay, so in this kind of embedding space, I would say that the word dog is more closely related to the word ant. You know, this is this high level of dimensionality that I was talking about earlier. Just on tomorrow, I mean, a particular class I need to go and prepare for that I haven't. I'm filling in for Jack that I think he can't attend, so I'm having to scramble. Lion, wolf, cat. You can imagine those being quite close in that sort of mental space, and that's what bias is it. This is those parameters that I was talking about earlier. This is what makes a large language model know stuff. This is those embeddings, you know, the way that goldfish really is so separated from spider. You know, they don't really have anything in common. We're thinking of this in terms of 3 dimensions, you know, X, Y, and Z. Imagine that across 185 billion dimensions, and you get a very, 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 very smart large language model, something that you and I can't even physically, you know, wrap our minds around. So that's what makes it so diluted, but, you know, that's what that is at a high level. For anything else, I would go and check out a little bit of a play with this website. So this is where you'll find all things open source when it comes to to foundational models. I said they're, you know, they are not few and far between. There's so many of them. There's a lot of them, and you'll find them pretty available now in all languages and across all fields. So Hugging Face is just a collection of it. It itself is not anything more than just a place to dump all these other people's work, essentially. So an emerging field, but hopefully one we'll talk about very, very soon. Cheers all. Thanks a bunch. Take it all very, very easy, and I'll see you on the next one.